This circuit is known as a combination circuit. It's combined series and parallel resistors. One series resistor, this one here, connected to these two in parallel, all supplied from this 9-volt battery. So let's look at the circuit analysis. At the moment the battery has got a voltage of about 8 volts supplying the whole circuit. The total current leaving the battery and entering the battery is about 64 milliamps. We do lose 5.2 volts across the first 820 ohm resistor, leaving us with a remaining 2.585 volts across the two resistors in parallel. The current in each of those parallel branches, because they're both resistors here are 820 ohms, the branch currents are fairly even, around about 33 milliamps each. Kirchhoff's current law states that the current entering a node, which is this value here, 64 milliamps, is equal to the sum of the currents leaving the node. In actual fact, it's the algebraic sum. So in a DC circuit, we'll say that the current entering this node position here, where the series goes off to the parallel, we'll say that is an ingoing current, so that takes a positive value, and the currents leaving to each of these two parallel resistors take on a negative value. So the total algebraic sum is 0 amps. Currents entering the node and leaving the node have an algebraic sum of 0 amps. It's a nice little circuit to analyse. Where some students come a little bit unstuck is they forget to realise that the parallel section of the circuit has its own voltage, and the voltage is the difference from the supply voltage, in this case 7.95 volts, and the voltage dropped across the series component of the circuit, 5.163 volts, and the remaining voltage for the parallel section is 2.566 volts. So all of the calculations for the parallel section will be using this voltage value. For example, if we wanted to work out what the power dissipation was on each of these two resistors, we could go power in watts equals V squared over R. We would use the 2.563 volts squared over the 820 ohms to get the power dissipated by that resistor there, for example, which should be the same as the power dissipated by this resistor here. So hopefully you'll find this circuit useful in helping you to get a better understanding of the combined series and parallel resistive circuit.